Welcome to Theory of Computation class. In today's class, I am going to explain the ambiguity in grammar. The ambiguity in grammar is possible only if that particular grammar will be derived with two different parse trees or two different derivations for the same input string. This is the general condition. So either you can implement a derivation for proving ambiguity, or you can use a parse tree for proving ambiguity. So I am going to explain both operations for ambiguity checking. So there are a lot of problems are available. So I am taking the first problem for proving ambiguous or not. So here they will give the problem as, they will give the grammar and they expect the answer as show that. So you should prove that the grammar is ambiguous, which means that it contains for the same input string two different parse tree or two different derivations are possible. We assume like that only. And there is no input string is given, so we should assume to take an input string. So I am taking derivation part first. In derivation, two types are available. So I am taking LMD first. Let us take the string id plus id star id. Okay, this is the given grammar. I write it separately. So the first production is E implies E plus E. Second production is E implies E star E. Third production is E implies id. So derivation means we should start from starting symbol of the grammar, it is E. Then this E can be replaced with either first production or second production. So here I am taking first production replacement. So E will be replaced as E plus E. Then the first E. So you consider the second symbol, it is a terminal symbol, it is already available in a given input string. This is an assumption of our input string. So the first symbol should be id. So this E will be replaced as id. Then the first two symbols are terminal symbols. You leave it. You can able to replace the next E. So this E should derive id star id. So I am taking the second production E star E. So you write that replacement productions within parentheses. So first symbol is terminal, second symbol is terminal. The remaining two non-terminals are available. So I am going to use LMD. So I am taking the first leftmost value, it is E, that will be replaced as ID. The remaining symbols are right as it is. Then the first four letters are terminal symbols, you write separately. And this last E will be replaced as ID. So I am deriving ID plus ID star ID. So this is first method. Then in second method, this is E. Instead of first production, I am using second production. So let us take the second production for deriving the same input string. So this is the condition for ambiguity. So if you want to prove ambiguity, you should take the same input string with two different derivations. Okay. So instead of using E plus E, I am going to take E star E. Here also I should use only LMD. So this E should be replaced. So consider the input string part star. The remaining symbols are three symbols should occur. So this E can be replaced as E plus E. Do you understand it? So this E will be replaced as E plus E. Then there are three E's are available. The first left E will be replaced as ID. So write the remaining symbols as it is. Then the first two symbols are terminal. The third one is non-terminal, that will be replaced as ID. Then first four symbols are same. The fifth symbol is replaced as ID. So it is derived. So consider the second step. The second step is different. So I can able to derive the same input string with two different derivations. So this is called as ambiguous. This is method 1. Method 2 is parse tree. So let us take to construct a parse tree for these two derivations. So I am going to take the diagram of first one. So LMD diagram. So this is E. So E will be the root node. This E will be replaced as E plus E. Then this E will be replaced as ID. This E will be replaced as E star E. Then this is replaced as ID. This is replaced as ID. So this is the diagram or parse tree for the first derivation. For the second derivation, I draw the diagram at the bottom. So E can be replaced as E star E. Then this E will be replaced as E plus E. Then this is replaced as ID. This E will be replaced as ID. This E will be replaced as ID. So if you consider yield of parse tree, so if you concatenate the leaf nodes from left to right, the input string will be available, that is yield of parse tree. So the first parse tree yield value is ID plus ID star ID. The second parse tree yield value is ID plus ID star ID. So same thing. But if you consider parse tree diagram, this diagram contains right heavy parse tree. The second one contains left heavy parse tree. So the diagrams are different. So you can able to prove either from the two different derivations or two different parse trees for showing ambiguity. So you take the previous problems. These are all three different problems. You do it by your own way for ambiguous checking. Thank you.